Energy, work, and power. Let's start with understanding the basic concepts. Conservative means that the force is independent on the parts, such as force of gravity. Non-conservative is dependent on the parts, such as your force of friction or your force of tension. If you see theorem in the question, always use your work net. Your work net includes all your forces. If you see energy principles, use your work non-conservative. This includes all the forces beside your force of gravity. Take note, power average equals force average, and you will use this when working with work. This is your work net formula. This is your work non-conservative, your kinetic energy, your potential energy, your power, and your mechanical energy. Now, these are all the formulas that you will be using in the section. Let's test what you have learned. The first one reads: a 5 kg block is moving down a frictionless incline. It passes point A with a speed of 4 and reaches point P. Point A is a height h meters above the ground. It then moves along a frictionless horizontal portion, PQ. The kinetic energy of the block at P is 285. Use energy principles only. Calculate the height h. Energy principles means work non-conservative. So you write your formula, you substitute everything that you know in, and you see that there's only one missing. If there's one missing, it means that there's one unknown and you're solving for your height. This is 0 because at the bottom P is 0. The height is 0. Give a reason why the kinetic energy at point P is the same as that at point Q. It's because there's no friction. The block finally moves in the rough inclined plane QR. It stops at point R, which is 3 meters above the horizontal, before sliding down to Q. The frictional force, which is a non-conservative force, between the surface and the block is 18 newtons. Draw a free body diagram for the block whilst it is sliding down from R to Q. This is pretty simple. You have your force of normal. Picture a block here. You have your force of normal going up, your friction going this way because it is sliding down, and your force of gravity. You can see the image here. The last one, calculate the angle of the slope QR. So we're calculating this. Now you could use your work non-conservative. So you do the same thing. You have your F, your X component, your cos of 180 equals your potential energy and your kinetic energy. So you have 18 because they told you at the beginning here that it was 18, and you have delta x and you're minusing 1 because it's 180, cos 180 is minus 1. Then you have substitute. The only thing you're solving for is your x. Your x is 7,67. Now you have to do trig. Sine alpha 3 because this is 3, and you solve for angle as 23,03. The next one reads: an object of mass 1,8 slides down a rough curved track and passes point A, which is 1.5 meters above the ground and speed of 0,95. The object reaches point B at the bottom of the track at a speed of 4. Name the conservative force acting on the object. The only conservative force is gravity, so the answer is your gravitational force. Is the mechanical energy conserved as the object slides from point A to point B? Choose from yes or no and give a reason for your answer. The answer is no, and that's because there's friction, and friction is a non-conservative force. So if there's a non-conservative force acting here, energy cannot be conserved. The next question. Calculate the gravitational potential energy of the object when it was at point A. So basically you're working out your EP. Your EP, you have everything. You have your 1,8, you have your 9,8 as your gravity, and you have your 1,5 because they tell you it is 1,5 meters above the ground. Next question. Using energy principles, calculate the work done by friction on the object as it slides from point A to point B. Work non-conservative. You literally substitute everything you have. You see that this is 0 because at the bottom here the height is 0. You're solving for your friction because that's the only force that's acting on this diagram. And you come out with negative 12,87 joules. Yes, in this section, they can be negative answers. So when you see negatives, don't get a fright and think it's wrong. As long as you do it step by step and substitute everything carefully, you should be able to get an A easily. Surface BC in the diagram above is frictionless. What is the value of the net work done on the object as it slides from point B to point C? The answer would be 0 because there is no friction and there is no other force acting on this object. The next past paper, in an experiment, a rough inclined plane QR has been constructed to stop a moving 5 kg block. The block reaches Q with a speed of 9,9. The block comes to a stop at point R, which is 3 meters above level QP. The frictional force between the surface QR and the block is 18 newtons. Use energy principles and calculate the angle theta of slope QR. Energy principles meaning work non-conservative. So you write your work non-conservative formula. The only force acting on this block is your force of friction. And cos 180 because frictions always cause 180, and the only thing you're missing is your distance. You sub everything in and you solve for your distance. Now you have to use trig to solve for the theta, and theta is 33,43. Moving on to the next one. A motor is used to lift a container of water up in a vertical shaft with a steel cable. The total mass of the container and the water is 987 kgs. The container is lifted from rest from point X and passes point Y at a height 46 meters. At point Y, the container has a speed of 0,9. You may ignore frictional effects and the mass of the steel cable. Now, work net formula. You have your force of gravity going downwards. You have your force applied, which is the motor. Now, you have to sub everything in and solve for the missing value, which is this. You have everything. This is 0 because it said from rest, and you come out to an answer of this.